Hopefully you can see that, chaps. Let's get going. It's 11 o'clock. This is in two parts, really, this blocks in automation. I'm going to do the first bit and everybody else is going to do the second bit. So I'm barely going to touch on types of sensors, but hopefully other people are bringing stuff along to talk about other sensors. The first person I know would be Julian. He'll be talking about his sensors. Blocks in automation. It's probably something you all think you know how to do, but I'm just trying to run through all the basics of how to set up blocks and what sort of places to position sensors, etc., so that there may be something there that would help you in your particular application. What is a block? Okay, in railway terms, it's a section of track that only one train should occupy in order to maintain safety. In model railway terms, it does more or less the same thing, but it also is developed to do other things for us. There may be multiple sections with feedback devices in each. So it's not just necessarily one section of track on its own with a sensor. Why use blocks on a model railway? Well, to ensure that one train does not run into another, which is quite important if you're dealing with O gauge and they're worth about £3 to £5 grand per train. To ensure signals are set correctly, to stop a train for specific reasons, for example at a station, a platform, uncoupling ramp, and to perform some sort of action like blowing a whistle or switching sound on or off. To show on a panel where the train's located. Not everybody uses blocks for all those reasons. Contact indicators. For a single contact indicator, a train approaching, the contact is off. As the train travels over the contact, it's switched on. And as the train passes, it's switched off again. So it's a once-off thing. It's only on while the train is over the top of the sensor. For occupancy sensors, for a particular block or section of track, the sensor is off as it approaches the block. It's switched on as the train or the locomotive enters the block. If the locomotive is still in the block, it's still on, so it's on for all the period of time that the train is in the block. And as the train passes through the block, it's then switched off. So they work in different ways. There's a section of track that's been fitted with a current sensor, and the green arrow describes the section that's being reported on. So if a train is in any part of that section, the current sensor will be switched on. Sometimes you can create a block out of two current sensors, and each of those separate sections will switch the current sensor will switch the sensor for the block on. And in some cases, you can use 3 current sensors. Typical block diagram arrangement for blocks, which sort of represents this kind of arrangement. Here we can see that we've got a block to the left, block to the right, and 2 blocks on the passing loop. The red sections are the ones that are detected by occupancy sensors. Examples of blocks, we can have them on the track at a platform, in sidings, whether they're hidden or open. Block sections on tracks between two stations that you may not want to stop there, but you may want to indicate that a train is passing through that section. In most cases, blocks contain only a single track section with no turnouts. They're usually limited by 2 turnouts on both sides or by turnout and a dead end section of track, as in some sidings. Block sections between 2 stations are often limited by block signals. Some guidelines for arranging the blocks. Blocks may be located anywhere on your layout. They're often limited by turnouts. These turnouts usually do not belong to the blocks. Blocks should be long enough to hold each stopping train completely. Now, I've got a double asterisk there. Hold that thought, and later on in the presentation, we'll come back to that. The more blocks are provided, the more trains can be run simultaneously under control. Each block should be reserved by at most 1 train. A specific train may reserve several blocks. So this would be a kind of forward planning for the route, where it can reserve several blocks ahead, and a good piece of software, well written, will actually do that. Blocks only need to be provided for the parts of your layouts which will be controlled. So if you have sections which you intend to only be manually controlled, then you do not need to provide blocks there. Here's a sample layout, stolen from a manual. Here we have 2 blocks for this station, 2 for this station. The fill-in blocks around the curves and some hidden sidings. In a very simplistic way, that is enough to run that layout automatically and to indicate quite reasonably where the locomotive or the train is. We could divide this block into more separate blocks depending on how long it is, as indeed you could divide the main block into several blocks depending on how long they are. And of course, fiddle yards are often quite long, and in many cases longer than the longest train, so you could get more than one in the same section of track. So you may have 2 different blocks there. Looking at that more diagrammatically, we have these blocks for this station, these blocks for this station, these blocks for the fiddle yard, and these are the ones in between. There are different states for a block. You can determine whether it's occupied or whether it's reserved. So you need to know whether it's occupied or not occupied, but you also need to know in automation whether it's been reserved for an engine or a train. An occupied block is assumed to be occupied if it's at least one of the indicators assigned to the block is turned on. You need at least 1 indicator per block, whether it's a contact indicator or a occupancy indicator sensor, and in some cases you can have multiple sensors in the same block. A reserve block can be manually or automatically reserved for an engine or train. Very often the control software will need to reserve that block ahead. Otherwise, when it gets there, there may be something else that's used it. For some very simple automated systems, they may not be doing that. But for a more complex, a more realistic automatic layout, then you will need to reserve either the whole route with multiple blocks, or just at least 2 or 3 blocks ahead, so that you know that the train can transfer into the next block. It's safe to do so. There's no existing train in that block. Unidirectional blocks. Some blocks may be specified as unidirectional. That is, that it can only be passed in one direction, and this may be on a piece of track which is a single track part of the railway. For proper operation, the automation system must be able to detect whether a train occupies a specific section of your layout, or when a train passes a specific point on your layout. This detection is done with contact indicators. Right, so in terms of arrangements, this is two-way. Trains can pass from left to right or right to left. This has 3 occupancy sensors. We have a block here separated by the white squares, a block here, and a center block there. And the purpose of these 3 blocks is to determine different markers. This orange marker is going to denote a braking marker. That's an indication for the locomotive or the train to start slowing down. And the red marker is a stopping marker. That's where you want the train to stop. So as you can see, coming from this direction, you enter the block. At this point here, you've now sensed you've gone into this second block and you're going to start slowing down. And by this point here, you actually stop when it hits this third sensor. So A, B, and C indicates the block is occupied. So any one of those on, the block is occupied. A or C can be used as a stopping point, but also for slowing down. You may or may not have come across that kind of arrangement, but we're just going to run through quite a number of different arrangements, because depending on your preference and your own circumstances for your layout, you may need one or other of these arrangements, and there's nothing to say you can't mix them on the same layout. So this is 2 momentary, one occupancy sensor and 2 momentary sensors. The same thing really. Train can come from the left or from the right. In this case, you've got 1 occupancy sensor separated by the white squares. And at point A, you have a contact sensor, and at point C, you have a contact sensor. So again, A, B, or C, any one of those that switched on would mean that the block is occupied. And you could use A for beginning to slow down, and C would be the stop for that direction, and vice versa, going back the other way. So that is another method of arranging a block. You can just use the 2 momentary sensors, and I do know that quite a few people do use this arrangement. Again, there's no occupancy sensor, just the contact sensors. Any one of these sensors switched on means the block is occupied, but also if the train hits A and it hasn't passed C, then the software and then the controlling software then knows that there's a train between them and the block is occupied. The same as a train approaching from the right. If it's triggered C but not A, then you can assume that there's a train within the block. It's cheaper to do that, but it's more difficult to keep tabs on occupancy. It's not a system I've ever used, but it's possible. It's a possible arrangement. You can do the same thing with 3 sensors. Why would you have that? Well, if you've got a particularly long block, you may want to have your breaking point towards the center of the block. In this case, if either A, B, or C are switched on, the block is occupied. If it's past A in that direction and not B or C, then it knows where it is within the block. So I've personally have not quite worked out what the real advantage of that arrangement is, but it is a possible arrangement for sensing locomotives in the block. And as you can see, we're not just sensing that they're there, the requirement really is to trigger things as well, events, happenings. Another what if the locomotive is just going from one way, so it's only ever allowed to travel from left to right, you can get away with 2 occupancy sensors. So B or C, but any of those 2 on would indicate the block is occupied. You can start slowing down at the beginning of B and finish by the time it hits the beginning of C. There is a way in which there's no need for extra sensors. You can just have one occupancy sensor, and this is in fact what I use, whereby as the train is detected to hit the start of the block at the beginning of block B, you start to brake and you stop a predefined distance into the block. How do we do that? The software knows the length of the block, say it's 150 centimeters. The software knows the distance to the stopping point, say 80 centimeters. The software knows the current speed of the locomotive, say 30 miles an hour, scale speed that is. The software knows when the block is entered. It can now calculate a ramp down of speed until the locomotive stops at 80 centimeters. There's a big but here. The locomotives must be profiled so that their instructed speed is their actual speed to scale. It's no good just taking a locomotive from a box, putting it on the layout and expecting the software to know exactly where that locomotive is, because all it's doing is giving it instructions through DCC in order to follow a set number of steps. If that set number of steps doesn't equate to an actual scale speed, then it can't accurately calculate where to stop the locomotive or the train. Variation on that is that we can have a shifted brake marker. We can, if this block is particularly long, we may want to stop well into it, and we don't want to start slowing down and have it gradually creep into a stop. So invariably what normally happens is that you travel into the block a set distance, and you define at that set distance that in the software that you're going to start slowing down there, and then you define your stop point. This allows you to have a more realistic slope down to stop, and the train doesn't suddenly stop on a sixpence, and it doesn't gradually creep into a station in an unrealistic manner. Good old train controller. Train controller provides all those controls, and you'll see that here this block's been set up such that it's going to travel in 10 centimeters, it's going to brake for 40, it's going to stop at 50, and coming the other way it's set up the same, but they don't have to be the same in different directions. So if you've got a platform at a station that's used for locomotives from either direction, which I do on my layout, then you may want to set up different stopping points. What does this look like? Well, here are 3 occupancy sensors: braking point here, stopping point here, traveling at normal speed. After it's braking, it ramps down to the speed to a threshold speed. Threshold speed is where it will still continue to run very slowly. It's a bit like a creep, really. Part of profiling a locomotive is to make sure that you set that accurately. You'll appreciate some locomotives require a bit more power to get them moving or to keep them moving than others. If you had 3 contact sensors, you get the same effect. So you can start, even with those contact sensors, you can see that the locomotive is going to stop where you want it. When to trigger. If the length of the train is known by the software and the distance to the first pickup wheels from the buffers is known, both front and back of the train or locomotive, and the length of the trailing coaches and wagons is known, then the activation of software markers can be on the head of the train, the middle of the train, or the tail of the train. You'll appreciate that you may have a position you want the tail of the train to clear, and in some cases it's just the head of the train's got to stop at a particular point. It may be that you want the middle of the train to stop at a particular point because you have trains of various lengths and you want to centre around the centre of the platform. So far, so good for stations and signals. What if we need to stop accurately to couple or uncouple wagons or coaches? We need to be able to set these stop and brake markers based on a formula that calculates the position of the chosen uncoupled point for a train. Train controller does it one way, other software will do it a different way. If you're using JMRI, you'll develop your own method. But you need to know what the total length of vehicles are, the total number of vehicles on the train, and so on. And a few examples of those. You've got a stopping point here. You'll need to pass the stopping point, and at that stopping point is an uncoupler, and you'll need to be able to calculate exactly where the correct couplings are over the uncoupler. It's possible to do that, and it's possible to have that on a variable formula such that you can then decide whether you're going to uncouple the last carriage or with the last 2 or in last 3 or in fact all of the carriages. it starts getting more sophisticated when you need to do these kinds of calculations. And then there was more than one. It's possible using software or sensors to line up more than one train in a block, say a fiddle yard. Software can best do this with varying lengths of trains, but if fixed lengths, then sensors could control it. I think we've seen some, I think there's one of the layouts on the virtual exhibition that's just been, the link's just been put onto the forum. One of those layouts, in fact, does stop more than one train in the same section of track. But I suspect they've got two different blocks and they just shuffle up the train to the empty block ahead. Software needs to allow more than one train in this block. What we're talking about here is that we have one block, but we want more than one train in it. By default, the software that I use doesn't allow more than one train to enter a block. You have to override that. There is an option to override it to allow more than one train in a block. I have my layout is Yeovil Town, and right at the front of the layout is a bit like a scrap line. It's where they parked all the locomotives they weren't currently working on, and some of them which were sort of long-term storage. So you could end up with 6 or 7 locomotives parked in front of the at the side of the engine shed. And you would need to be able to, if it was done automatically, you'd need to be able to bring one up against the other one without crashing into it. The software would use an assumed distance from the tail of the previous train in the block to set up a dynamic stop marker for the second or third train. Easy if you just got one locomotive. You can easily tell the software how long that locomotive is from buffer to buffer. And if you want to stop another one after it, you can add a bit of dimension between two, a bit of space, free space, and then for the third locomotive, you can then bring that up to it. Same can be done with trains. 2 or 3 trains in a block. So here we could stop the first train at the end of the block. Software knows how long the train is. It's added on 10 centimeters, say, and we now have a dynamic stopping point here. The next train's coming in. It can then pull up at that dynamic stopping point. It knows the length of that train. There's only one carriage on that train. Adds another 10 centimeters on, and it's got another dynamic stopping point, of which another train can approach and stop there. So it is possible just using one occupancy sensor. If the software is sophisticated enough, it can stop more than one train in that block. I haven't done it. Might try that sometime. The double star, what does it mean? In the true sense of blocks, they will always be longer than the longest train. However, with many block detection modules, there are usually more ways than needed. So why waste them? If there are short sections of track, then add an occupancy sensor so that you can use it to trigger an event or keep tabs on the train. If a block is across a baseboard joint, then use 2 occupancy sensors. Thank you. And declare the 2 blocks as one longer block. So I've actually done this. I've got a block which had a baseboard joint across it. I've got 2 occupancy sensors, and I set those up and just say these two sensors are the same block, so either one of them, and the software can just treat it as one longer block. I've also got short sections of track which you sometimes can struggle to put well, in many cases actually struggle to put a whole train in, but they can be used to trigger other things to happen. And if you find that you're not using them, you can always tag it on to the an adjacent block and extend that block. But I'm firmly of the opinion is why waste the occupancy sensors that are spare. They tend to come in blocks of 8, and sometimes you can get 2s, but some of the commercial ones are usually in 8s or 16s. What do? I use just one occupancy sensor. I profile all my locos. It's a long job, but very, very rewarding. I use the software to stop the train within a centimetre easily, sometimes better. I've used LDT block detectors. I can show you an image of one later, but I'm changing to the DigiKeys DR5088 RC to obtain Valcom. But I've yet to prove that system, and I've got a test bed side of me that I'm building to prove that that's going to do what I want it to do. Member participation. Right. I've gone through the blocks. What we need to cover now are the sensors. Julian's going to demonstrate some simple sensors he's been developing, and then hopefully other people can chip in with different and various types of contact sensors or occupancy sensors, so that we as a group can understand the different ones that are available to us to use, hopefully giving us some pros and cons as well. Okay, any questions on what we've done so far?
Paul, yeah. I was a bit surprised when you said that the points weren't included in any of your sections. I wondered why. Was there any particular reason?
I was advised when I first got into automation not to do it. It isn't particularly necessary, and it only leaves part of the layout uncovered, really. I mean, in a sense, you could have a whole layout with only 2 or 3 blocks on it and still perform a reasonable amount of automation, in which case they do. My club is building a club layout in these difficult times, which is 00, and it's quite a large one, and they only have blocks in places where they want to stop a train. They don't have anything in between. They only have sensors in a few places. Yet it will run automatically. Obviously, there's one on each line in the fiddler yards. They've got 2 fiddler yards, so all their points are not covered. It's just my preference, really. I know people do include turnouts, but it's not what I do or have been advised to do. You can end up with some complications. Presumably you're using turnouts, are you?
Yes, on the little layout that I had done, I'd always included the layouts. I'm now starting on another layout which will have a few more points. It won't be very large, and I'm just sort of determining where my blocks are going to be and which block I'm going to include a point in. One of the things that does occur to me, if you're sort of wanting to know where trains are and you've got a mimic diagram, then if you've got a
Yep.
short loco and it goes over a point, it's going to disappear if it's not detected.
The only thing that I personally have would be a single engine that would do that. I have nothing short enough to disappear over a point, because typically the blocks terminate just before the point and start again just after. But I'm not so sure. I'm not so sure that everybody wants to use their blocks for just indications on a mimic. It's a case of are you trying? Is the main reason for using the blocks to show it on a mimic exactly where the train is, or are you trying to? I mean, you could. There's an argument to say that you could predict where the train is between the two blocks, but and software is quite predictive anyway. But I've not found that that's been a problem when I've been demonstrating or running my layout. But it's a case of personal preference, John.
Yeah, I suppose it was historic really. The first one I wanted the mimic diagram and I put all points in so they showed. But then this next one, I'm just wondering whether I need to or not. From what you're saying, I might better leave them out. I'll have a look at that and see how well it works for me. So that's.
Did you find it?
Sorry. From the perspective of a train controller user, it's possible in train controller to have a contact indicator assigned to a specific turnout, which is not the same as it being in a block. And the advantage to that is train controller, well, you can first of all show on your train controller diagram that the turnout is occupied. And secondly, it won't throw the point or route anything through that turnout if the contact sensor assigned to that is occupied. So for my layout, I certainly put all the turnouts, put occupancy sensors for all the turnouts. You don't absolutely have to do it, but I think it's probably wise. Not the same as having it inside a block.
Okay, James.
Okay, yeah. I should be using JMRI. So okay, I take your point about the ROCOM and those particular ones. But okay, thank you.
In JMRI, you have to include the turnouts if you're doing any sort of automation, otherwise it simply won't work.
Yep, that's a very good point, actually. Definitely to be included in JMRI, otherwise, as I say, it won't work. The special signals, it will really confuse it if you don't include the turnouts in all the blocks.
The blocks have to be connected together for the train for the system to know where the train is and to pass the information on to the next block.
Yep, that's right.
Okay, thank you. That's very useful.
Okay, that's good. Good.
I have a couple of questions, Paul, or thoughts on it. And the first is to do with train length, which you mentioned when you're talking about having multiple trains nose to tail in a fiddle yard, and how best to calculate the train length. I mean, it occurs to me that if one has two contact sensors along a length of straight track, then a train passing over those, it can calculate both the speed of the train and the length of the train, as long as there is debouncing on the contact sensors, so that, for example, a gap between a loco and a carriage or a loco and a wagon wouldn't be registered as the end of a train and the beginning of another train. It would calculate from the beginning of the locomotive to the passing of the last vehicle. And could therefore use software to say, okay, this train travelling at this speed must be this length.
Yeah, there's several ways of doing this, Andrew. Certainly in Train Controller, you tell the software exactly how long each carriage and each locomotive and each wagon is, and then you assemble in software that train. So the software package knows how long that train is. You could quite simply, I suppose, override that. If it's a fixed train, never going to change, you could put an overall length into JMRI or something like that. But yeah, you're talking about a dynamic sensing of the length of the train. But But would it always pass that section of track? And
Yes. I mean,
would it always?
the kind of automation that I'm thinking of is not quite this kind of automation that you're talking about, where a complete layout would be fully automated. I'm talking about the kind of automation I'm thinking about is something where part of a layout would be completely automated and the other part would be operated by humans. And as soon as you have humans operating it, you've got errors, you've got mix-ups and things. So for a train to be able to pass from a human section into an automated section, the automated section has to know what's going on with that train and has to gain all the relevant information about the train, which it can either do by being told, where there's possibilities of error, or it can do by calculating it, where it can get it right. The other thought, which you didn't touch on, but is sort of kind of relevant, is with occupancy detection, you can have an added protection against a train becoming uncoupled, particularly if you've got a contact across the wheels of the brake van at the rear of a train. If the train becomes detached halfway point along a section of track, the locomotive carries on, but the brake van is still showing that that track is occupied. We assume that the train has arrived in the fiddle yard and not realise that there's a brake van and 6 wagons sitting out on the track somewhere.
Right. Okay.
Something else, if I could just mention. One thing to think of is something I've done on my layout is where you have, for example, a turntable where you've got a lot of radial tracks. You know that only one of those is going to be in use at any one time. So what you can do, rather than putting a sensor on every radial, or you could do it in a fiddle yard, the same thing, you can use the same sensor. And in my case, what I use is a Merg accessory decoder. And with JMRI, I use the lights function. So basically, I just use one sensor and I just basically switch it with a relay to the appropriate track. So I don't have to have, it's cheaper, you don't have to have a sensor for every block. If you know you're only going to use one of those blocks at the same time, you can share the same sensor and use an accessory decoder and a cheap relay board to share the same sensor between all those blocks. And then in your software, you have like a virtual sensor, which just detects what's occupied and what isn't, and that keeps track of where everything was. You don't need a physical sensor. So that's quite neat.
Does that work quite well with multiple trains running at the same time?
Well, that's the point. If you've got something like a turntable, you're only going to be using one of those radials off the turntable at once. So, so there are only certain cases, but you could do it in a big fiddle yard if you knew only one thing in the fiddle yard was going to be moving, and you had a whole load of different tracks. You could use the same sensor and just switch it with an accessory decoder and a relay. And it saves quite a lot of money. And I've done that on my layout. One other thing I was going to mention, the thing about having multiple locos in the same block. I do that on my layout. I've got 4 in the same siding, and they're different lengths. And when the first one moves off, all the ones behind just shuffle up. And then the one at the one to leave space for one at the back. But it isn't very accurate. I'm finding I'm having to leave really a loco's length between each one because of the accuracy of shuffling everything up. Otherwise they crash into each other. So it's not great, but it does work. You do have to leave quite a gap though for it to work.
Presumably run at a creep speed.
At creep speed, but it's not that accurate because the locos are cold, they don't respond very well, and blah blah blah. The other way I was thinking of doing it was having all the locos actually all bunched up, pushed so they're touching each other, and then when the front one moves off, move them all together, but have like a sliding scale of speed. So the ones at the front move slowly and the ones at the back move more quickly, so that they never separate. And the ones at the back are kind of pushing the ones at the front. And I haven't tried that yet, but I did wonder whether that would be a more realistic way of doing it, and maybe a better way of doing it. And you could fit more in the siding as well, but I've yet to try that.
The risk with that is that you end up with them all coupled together.
Well, yeah, they'd have to have no couplings on. Yeah, sure. Yeah, it would only work with if the locos were dedicated that with the couplings taken off. Yeah, for sure. But it's not a great way of doing it. It's really not that practical. The other point I would mention on my implementation, you mentioned about locking the blocks. On my system, the JMRI, what I actually do is the scripting I've done actually locks the points, not the blocks. On the basis that if you haven't got any points, you know the block is either clear or the sensor is going to say there's something there, so you don't let the loco go in. It's only when I've found it better that you only need to worry about the locking when doing it by locking the points rather than locking where the blocks where the loco is going to do. Effectively, it does the same thing. I just find it's easier to think about doing it that way. Yeah.
Okay, we've got a question from John Cartel.
Hi there. Hi there.
Cartel.
I missed the first couple of minutes, so you may have covered this, but does all this that you're saying presuppose you actually know the ID of every locomotive, or are you using something to detect that as well?
It presupposes you know the ID. I've not really got into Railcom yet, so I've not played around with trying to put a rogue locomotive on and deciding what to do with it from there.
Okay, thanks.
But the sensors work. The contact sensors and the occupancy sensors work. Whatever you've got there, as someone's already mentioned, it could be a stray wagon that might be a brake van that's come off the back of the freight train.
Yeah, but if you want to stop a loco, you've got to know which one it is in the software, don't you?
Yes. Yeah.
Paul, regarding profiling,
Yes.
I semi-profile because I stopped from a point detector. But how do you overcome the problem of a loco actually warming up and having different characteristics to when it's cold?
I don't really. As you profile them, you're profiling it as it's warm. I've not come across great differences because in profiling you take out a lot of the variation. In profiling, you're setting the start current, the start voltage. You're setting the top speed of the locomotive, and you're profiling the locomotive through its speed range, both forward and reverse. I don't know what you've done, but certainly I've not particularly had any problems with them being cold or warm. And I have 20 odd locomotives on the layout, and they all start from cold, and they complete their sequences okay.
Oh, they simply stop quicker when they're cold. That's all. So if you do it when everything when they're warm, I suppose that solves the problem.
Well, yeah, I suppose it depends on the gauge and the type of locomotives you're using. But certainly the ones that I have on the 4mm scale, I don't have a particular problem between cold and warm on the automation side. I know people do, and there is a difference, but I haven't seen that personally as something that's. I mean, I have automatic sequences which are stopping at a station, but I also have them stopping in a bay platform. I haven't not had quite a few places where they're stopping in a bay or with a buffer, and they don't tend to crash into the buffer when they're warmed up. So yeah, so I suppose we can only do the best we can with them being being warm, really. I've, as I say, I don't know what that's like in N. Maybe somebody else has got an N gauge.
Yes, mine are N. Yeah,
or an O gauge. Yeah. So do you see much difference in between the two?
It's certainly noticeable if they're if I do it when they're relatively cold, as the stopping distance changes from when they're warm.
Yeah, I
How
agree.
much? A centimetre? 2 centimetres?
Yeah, 2 or 3 from let's say 25%.
2 or 3. Yeah.
Well,
Okay.
could I have a word on my Engage
Yes, John.
layout? My profiling has been less sophisticated. I have a maximum, what I call a maximum, normal, and minimum speed for each loco set by testing, and I use the acceleration and braking CVs in DCC to mask the transition from those through speeds. And I've not found it a problem in Engage in the warming of locos to be a problem. I can usually stop the locos in the sensor and bring it to a halt with a read contact switch. So maybe I'm just fortunate in Engage, but that's been my experience.
John, you're using sensors to stop the locomotive, though, aren't you?
I might use a sensor to go from maximum to normal, another one from normal to creep speed, and then a contact sensor to actually bring it to a halt. And then the contact sensor in the software, I might set a delay after getting the contact sensor to bring it accurately to a halt.
Yeah, the variation would come if you're using, say, one occupancy sensor and trying to use a calculation or the software to predict where it's got to stop.
Yeah, well, my software doesn't offer that calculation facility, you see. So it has to be much simple.
But this is why for different people with different layouts, you're going to end up with different arrangements of blocks and different contacts. You've chosen, when I first started in automation, I said, okay, I'll start out with one occupancy sensor, and depending on how accurate the stopping distances are, we'll decide whether I put any contact sensors in to stop them precisely at those points. And all I'm saying is, in my particular instance, I've not found any need to put those extra contact points in, contact sensors in. In fact, the only place that I'm planning to do that is where I need to stop a locomotive over a set of points. So what we're looking at is different layouts are going to be using different arrangements for different reasons. So yeah, I can remember your layout when you presented it earlier, John.
Oh, right.
It worked quite well, didn't it?
Can I just show you a picture? Won't take a second. If I can find it. I don't know whether this will work. Hang on, I've not done this before. There, that's the layout. Can you see that? Can you see that?
Yeah.
Yep.
Okay. Yeah, we can see it.
Well, this was originally train controller, although I'm not using train controller now. And you can see the blocks. And because it was a layout built 15 years ago, never for automation, there are very few blocks which are longer than a train. The blocks are determined by the gap I set at the frog for every point. So in other words, between the points is a block. And so you'll see, for example, in Riffin's Junction, which is a dead end, the platform's divided into several blocks, and usually there's a reed switch around to bring the train to a halt. And so this is what you have an existing layout where you can't have blocks longer than every train. and you just have to manage it with the software. Every block in my system is designed for an arrival or a departure situation.
Yeah.
So it's not a sophisticated system like Train Controller. I have to set up routes pre-programmed, so it's not automation quite the same way. I have to set each route up manually. So that's the difference.
Yeah. Okay. By the way, I've just noticed someone's mentioned, does anybody use iTrain? I've got a copy of it for evaluation. I do intend to obtain a full copy of it to test on my layout at the side of me in the office here, and compare it with JMRI and Train Controller and anything else we'd like to use in the future as well. So my local club is planning to use iTrain on its new club layout. So yeah, people are beginning to pick that up. It's and there was talk on the forum a little while ago saying that iTrain has now suggested it's possible that they may consider developing an interface to CBus. So that would be good news for NERG members. Ron, you've got a question?
Yeah. When you talk about profile, do you store the profile actually in the software or on Loco itself?
In the software.
It's actually in the software. The software. Okay. Okay,
Yeah,
that's fine.
yeah,
I thought
yeah.
in CVs or something like that. Okay.
No.
Right, that's fine.
But where would you store it in the Loco?
Well, I was thinking that setting up the accelerations and decelerations and the brakings in the CVs and things. I'm not too sure.
Well,
I've not done it. It's just a
depending on whether depending on what software package you use, depends on whether you use acceleration and deceleration, because certainly with Train Controller we switch those down to 0, so let the software accelerate and decelerate the locomotive. Otherwise it's got an unknown, hasn't it? The software wouldn't know what you set.
Well, if you
that particular locomotive to.
Yeah, I just wondered.
Unless it read it.
I just wondered if you could normalize all the locos by setting the acceleration on each individual loco. You could normalize it so that you have a fixed acceleration for all the different locos.
Well, you do. You set it at 0.
Yeah. No. I mean a constant. So the software, the main software, will always know that a loco will accelerate and decelerate at a particular rate.
I'm sure you could do that within JMRI or other open source software, but James will correct me if I'm wrong, but I don't believe I can do that in Train Controller, and I wouldn't know about iTrain yet, whether that allows it.
Okay.
But certainly,
it's manual specifically.
Certainly normalize. Sorry, I didn't catch that.
Sorry, I'm not sure there may be a slight delay. Just to confirm, Train Controller doesn't support setting non-zero acceleration values, and the manual specifically says to set it to 0. I don't know about other software, but it doesn't work.
Yeah. So when you talk about normalization of locomotives, I mean, part of the reason for profiling is the fact that if you set a locomotive going at 30 miles an hour, whether it be a freight train or an express, they will travel at the same scale speed. And that is very reassuring when you're setting up automation, to know that you can actually control the speed within 5 or 10 miles an hour and make it a realistic speed as well, scale speed. Although, like everything in our hobby, a scale 30 miles an hour isn't always the best thing for an exhibition module. You sometimes want to run quite slowly, and sometimes you want to run fast, much faster, to give an impression of the differences. Julian, are you going to carry on with your presentation?
Sorry. Okay. Right. Can you hear me now? Can you hear me?
Julian.
Okay. Fine. I can't see myself. Why haven't I got myself on the screen? What's happened?
We can see
What's
you.
happened, Paul? Oh, why can't I see myself?
We can see you.
Okay, I'll have to do it from the little screen. Oops, this is annoying, so annoying. Okay, I've developed 2 new sensors. They're just the sensors you need, guys. I've emphasized simplicity, cost, and ease of use. And there are 2 sensors, and on the forum you can find details of them. I'm only going to talk about one of them, but I'll just mention the other, which is an occupancy sensor, which is a current sense occupancy sensor, DC sensor, and it's very, very simple, and I'll just show it to you briefly. There it is. It's like the double diode sensor, but without the diode. It uses a MOSFET instead. So the other sensor is an LDR spot sensor, and what Paul would call a contact sensor. So it's just an ambient light spot sensor. And I'm sure you all know that an LDR, light dependent resistor, has a resistance which decreases as the light intensity increases. So at high light intensity, when the loco is not over it, it'll have a resistance of a K or so, 1, 2, 3 K. And when the loco obscures it, it has a resistance of several hundred K. I'll just show you the circuit that oops, got to switch the camera. Switch camera. Okay, there's my circuit. Now, you couldn't get much simpler than that. And I hope you can recognize a voltage divider, and the center point of the voltage divider goes to the analog to digital converter input on the PIC. So I hope it's clear to you that when the light falls on the LDR and its resistance falls low, the voltage at the ADC input is low, and vice versa. When the loco obscures the LDR, its resistance goes up and the voltage goes up, and the PIC can detect the difference in those 2 voltages very, very easily. But the problem, of course, is that you don't know the value of the LDR resistance, and it can vary by a factor of 4, and you certainly don't know what the ambient light is. And most people overcome this with a potentiometer, or also I've seen quite cleverly a reference LDR is used, which measures the ambient light all the time. What I've done is have an automatic trip level which tracks the ambient light. So you've got a low ambient light, and the trip level is, in voltage terms, 800 millivolts above it. And as the ambient light goes up, the trip level goes up, and it tracks it all the time. I'll show you that on the scope. I do have in front of me an actual one, so you can see it. If I can just, oops, sorry, I've got to switch the camera. There we go, here we go. There is the actual, is it going to focus? Yes, there we are. There is the actual LDR TOTI. And on the left, you see the DC, 5-volt DC supply in. I've patched in the ADC input so we can look at it on the scope. Okay, let's go to the scope. On the scope, we have the, switch on, that would help. Okay, the scope shows you the ambient light level. Now, if I put my hand over it, it obscures the light and the voltage goes up. So that's what the ADC is looking at. That's with light, without light. And you can see that that's fairly clear to see. And if I switch a light on harder, the ambient light which goes. And if I switch it off further still, the ambient light goes up. Now I'm going to switch on the other channel, which is the output channel of the scope, and I'm going to switch the trigger to normal trigger. So there we have it. The output triggers when when I put my hand over the LDR. Now, if we put some cursors on, we can actually make some measurements. And I've already set up these cursors for this light level. And here you see the ambient light level, which is, you can see from is 640 millivolts. And the trip level, 800 millivolts above it, is at 1.44 volts. Now, so whatever I do, the trip level is always at that 800 millivolts above the level. Now, if I bring the ambient light very, very high and do the same thing, now you can see that the ambient light level has gone down, but it's tripping at a lower level than the previous light level. There we go. So that's the basis. Now, I've used this on a new block system. I described a block system in the journal in September and December of 2019, and it uses the Lens ABC system, which I'm very keen on because it produces many more bangs for your buck. Here I've got, I'm just going to remove the scope. Now we've seen the scope, I'm just going to remove the probes and switch it off. So we can see the test track. Well, you would be able to see the test track if I switch okay. Here's the test track. It's got 3 sections now. I've got the normal running speed section, the slow approach section, and the slow down and stop section ahead of the red signal. I can turn that signal to green, I can turn it to red. Now, if I send the train on its way against the red signal, whoops, we were talking about, this is so stone cold, and it's run a bit further on than, it's run several centimeters further on than when it's, okay, now I'm going to run one more experiment, which is to run it slower. There we go, and I'm going to add a wagon, because the great advantage of the, sorry about that, the great advantage of the LDR sensor, okay, let's have another go. Okay, it stops at the warm spot. Okay, so the advantage of this system is there are no cuts in the track at all, and there's only one feed from the electronics, which is there. And as we saw, it works with a push-pull loco. Oh, I haven't shown you the LDRs in the track. Apologies again. There is the LDR. Can you see that? Is it focused? Yep. There we are. There's the LDR. The Hornby 00 track has a very convenient screw hole into which the LDR exactly fits, and the other one is in the stop section, and that one's there. You can just see it there. So those are the sensors which you guys need. There's the DCC occupancy block sensor, which Paul talked about, and the spot sensor. There's the back of the contacts are all on the back of the spot sensor. Oops, there we go. No, okay. And there's,
what's the output section of the LDR board?
The output.
What?
It's just an output, but of course you could. I've got another version which Yeah, I've got another version. Yeah, there's another. I've made another version, which I've put an optical isolator on the output and a power supply. So you could run it from any old power supply and you've got an optical isolated output, but it's really up to you. This one, because it works with my block system, just provides a 0 volts, 5 volts and signal out to the block system. So it's got a very sound common ground system. So I don't need the optical isolator in my particular case.
All the details on the knowledge base?
They are, at the moment, they are on the forum, but I think you'll find plenty of details there, right. And you can always send me. I'll be doing an article, but that won't come out until next March. But there's quite a lot of detail on the forum, and you can always contact me if you need more details.
James, did you need to ask a question?
No, sorry, that was the applause reaction, not the question reaction.
Okay. That was quite a hairy to do that demo, I can tell you. Okay, next victim can sign in, Paul.
Right, okay. Has anyone else brought examples of sensors along that they use and they find would be useful in this situation?
I haven't got a different kind of sensor, but I can share one or two things that I've learned about using ordinary occupancy sensors that might help.
Okay.
Just a couple of things. First of all, in the particular layouts that I use or that I'm either building or planning, and none of them I've actually completed yet, so my experience is from something that is still at a fairly early stage. But my layouts involve instances where locomotives have to back onto carriages and couple up to them. And one particular complexity arises there that wasn't directly dealt with in the presentation and isn't really mentioned in the train controller manual. And I, as Paul says, use train controller, which is this. If you've got a block where you've got carriages, and assuming that your carriages have either carriage lighting or resistive wheel sets so that their position can be detected, if in your station you just have the one block for the platform, if you're backing a locomotive onto your carriages to couple up to them automatically, your system can't detect the locomotive has entered the platform section because it's already occupied by the carriages. So you have to find a way around that. There are a number of possible ways around that. The way that I do it, and probably the easiest way for a pure occupancy sensor system, is to use a short lead-in section. So between the last set of points and where the carriages will actually stop, you have a very short section, not necessarily a separate block, but a short occupancy section, so that the locomotive entering that section can be detected and your stop and brake markers can be set from that occupancy sensor section. And anywhere where you have a locomotive backing onto carriages or wagons, you need to have that kind of system. You can in principle do it with a light sensor or infrared sensor or something like that as well, but including the system that Julian has just demonstrated. I do it with occupancy sensors because I like to have a consistent system, but that's an important consideration. One miscellaneous theoretical thing that may be of interest and perhaps marginally to some people that I haven't implemented but I'm considering. In cases where you have hydraulic buffers in a platform and you have a situation where you want the trains actually to buffer up to them, it might in theory be possible to install little micro switches in the buffers so that when you press the buffers down, you trigger off a switch and that can end up being your stop indicator. I haven't tried that. I'm thinking about that on the planned double low gauge lamp. That's way off yet. I hope that's of some interest.
It's a good idea, but you need a modern image thing for hydraulic buffers, won't you? It's
I think they were around in the late 19th and early 20th century, weren't they? Yeah, early kinds. They've been around for a while.
Yeah. Yeah. Okay.
Your point with regarding to reversing onto the carriages, can you not, if the block sensor is active already because of the stock that's in there, can you not detect when the loco leaves the previous section that it's just reversed out of? Is that not
It is
tell
possible.
you when it's entered the section?
Yes, you can do that. And when I built a small automation test bed a couple of years ago, I did do that. But there's a problem with that, and that's this. For leaving a section, the time at which that happens is much less sensitive than the entering a section. And that's because the occupancy sensors, at least the current draw type, have a D-band setting. And certainly ones that I use have a minimum D-band setting. And they have that because otherwise you have a slight track and the detector actually left. So yes, you can do it, but it's less accurate, and I advise against it for that reason.
Yeah. Okay. Understood. Thanks.
No more examples of sensors?
I'm a big fan of the hall sensors that Moog use, providing you're not sharing your layout doing exhibitions. If it's just your own, tiny magnet on my N-Gage locos with very, very cheap and very effective hall sensors. Works an absolute treat.
The hall sensors more reliable than the read sensors.
Was that a question?
Yes.
Oh, absolutely. They're super reliable. They're really fantastic. They work every time. You just in N-Gage, the size of magnet has to be fairly thin, but you can get 0.5 mil thick magnets of various diameters, and occasionally when you can't put the magnet at the front of the loco, then you have to either get a bigger one and put it in the middle, because on curves it wouldn't sense it. But generally, they're perfect in every way, and they're dirt cheap, so it's great.
There was some talk about the Hall sensors triggered by falsely by a motor on a locomotive passing on the parallel track or so. Have you seen any of that? Or?
No, they are pretty insensitive in my experience. Certainly the magnets that I use, they have to be positioned right on top of it, otherwise they don't work. So no, I had no interference at all.
Okay, thanks. Thanks for sharing.
Has anybody done any comparison between the LDR type and the infrared types?
I don't know if they have. You mean infrared? You mean hectors and things like
basically, yes.
Yeah.
I have only experience with the old Hector, and the problem there was really you have to have a good reflective surface, and some black plastics don't reflect, so you don't trigger. And that is supposedly fixed with a newer Hector, but I haven't tried that yet.
They're a bit big for N-Gage anyway.
You can get very small infrared transmitter receivers that will easily go between the track on N-Gage. I'm not suggesting we actually use a Hector as such. It was just the principle of a infrared LED reflecting to a sensor. Julian, did you have any comment? Were you going to have any comments on that?
Who was that question to, John?
To Julian. Has he tried any different type of sensor? Because I'm worried about the LDRs unless you have a reference sensor.
I don't know if Julian's still online, actually. I can't see him.
I noticed with Julian's demo that he was triggering the sensor by waving his hand over it. But once you've got the thing running on the railway, you walk near it, you're going to trigger his sensor because you're going to be casting shadows as you move around. And it's a sort of a setting which have a comparator LDR or similar to which get around this.
He wasn't trying to trigger it with his hand. He was trying to show you the threshold.
Yeah, and he was doing that by
as ambient.
Doing that by triggering it with his hand. Now, I don't know how close he had to get to it, but if you've got fairly bright lighting onto a layout and you walk between the layout and the light, I think you're likely to trigger it because his threshold it tracks it, but it doesn't track it very quickly. and you know, moving around, you're going to have a quick changing shadow which the threshold won't track.
Roger, you'll have to build a few and do some tests.
I started testing with hectors actually to get around the reflective problem and other problems. Instead of having it as reflecting, I'm inverting the logic and making it transmit a beam and detect the beam. The loco breaks the beam, which is reverse to reflective. But of course, I've got to rejuggle all the software because the debounce timing and everything else is wrong for that way of working. So debounce is the exit rather than the entrance.
Well, one of the advantages of the Hector type is they've got inbuilt compensation because you're pulsing the LED, the infrared LED, so you can measure the difference on the receiver when the LED is on and when the LED is off. So that can set your background light level, as it were.
If you're breaking a beam, the laser detector works very well indeed as well.
Well, it's basically the same principle, isn't it?
You can also you can also use this rather than breaking a beam to use it to make a beam instead. One of the problems that I'm struggling with is shunting, where you need to stop a train with a coupling precisely over an uncoupling magnet. And for that, you'd have to use some form of passing contact detection. But most of the passing contact detections, because they're working on a light beam that gets broken, the detection is triggered by the shadow of a locomotive or a vehicle passing over it, which you'd have to have it. It doesn't tell you where the coupling of the locomotive is. It tells you where the locomotive is sort of beginning the body of the locomotive. But you can get round it. The way I'm thinking of getting round it is by painting a dot underneath the locomotive or underneath the wagon, a precise distance in from the end of the wagon, such that I know that if the wagon is or the locomotive is over, if the dot is over the detector, it would reflect the light back. You're using either white paint or silver reflective paint. That would reflect the beam back, and it would then trigger an LED on the control panel to say this locomotive or this wagon is in exactly the right place. Ideally, you have two detectors either side of the uncoupling magnet, and both the locomotive and the wagon would then be placed exactly, would both trigger their detectors, and then you know that the uncoupler is right over the magnet, and you can then reverse the locomotive off.
Well, Andrew, that is actually one of the advantages of using the infrared ones, because in fact, no, you're quite right, because the infrared one would reflect off the black from the body.
Yeah.
You would then have to use a visible light one.
Yeah. So it would just using a white dot instead, or a dot of reflective paint, would give you a more precise way of detecting where the body of the locomotive is, rather than simply that an end of it has passed over the detector. The other thing that I thought I might share is a similar but unrelated system used on the Fallow Road vehicles that I saw implemented on a layout, where every vehicle driving along the road is fitted with both a reed switch and a magnet. And at various points along the road, there are either magnets or reed switches. So when the reed switch on the vehicle is triggered, it stops the vehicle. So a vehicle driving along the road, when it encounters a magnet that is turned on, will then stop at that point. When the vehicle is driving along the road, if it passes a reed switch, that can then trigger something to happen, a magnet elsewhere on the layout to go on or off. So you can have a point where a vehicle drives along, triggers a reed switch in the road, which then releases a vehicle that is parked up ahead of it for a few seconds. So that vehicle would drive off, and the first vehicle would carry on driving. And once it's triggered it, the electromagnet would then come back on again. So the first vehicle would then stop where the other vehicle was. So you have a situation where one vehicle drives along the road, drives behind a building, stops, and another vehicle drives out from behind the building. And it allows the traffic on the road to be swapped around from vehicles appearing and disappearing. So you get the appearance of there being a lot more traffic than there actually is. And it was a rather clever method, I thought, of having controllers on both the vehicle and in the road.
If I could just offer something that I've sort of prepared earlier. I've been experimenting with working out, I was actually originally just looking at signal control, but I've got here, I'm going to try and move my screen so you can see what I've got, but with regard to the sensitivity of the infrared. I don't know, can you see?
Almost.
Almost. Is that better?
Got on it. Yeah, could see an Arduino Uno.
And a breadboard?
No, you need to pull it back towards you. Well, yeah, back towards you, Roger.
Yeah. So I've been defeated quite a bit because I bought a pair of these sensors and one of them was broken when it arrived, and I thought it was my wiring and everything else. So that hence me setting up this little simple display. But in terms of sensitivity, I just thought I'd show you, if you can see my finger approaching, and I'm very, very close.
Ooh.
Have you got that?
Yep.
So it is, and then I've actually, there's a potentiometer on the board, which allows you to set the height of it before it comes on as well. And the other thing that I found on YouTube was a guy, I think he might be Austrian or something like that, and he promotes, rather than have this issue of the gap between two coaches or two wagons, of taking off one of the sensors off the board and putting a length of wire on to the other side of the board, and then setting it up at an angle across the track. I'm not very good on my angles, but probably 45 degrees, something like that, so that when the train's going past and then it gets to say the first coach, it doesn't see a gap because of the angle of the beam, and then you only get the end of the train when the end of the train really appears. Does that help?
Yep, that's good. I think as a group we will need to investigate sensors in a much deeper way and maybe get some empirical data as to how good, how sensitive, how reliable, what sort of surfaces will things reflect off, what sort of situations it will cope with and won't cope with. So we'll have to have some kind of thing, maybe put it up on the website as to a comparison and maybe suggestions about which situation to use which type of sensor in. But certainly the laser one, I've got a kit which I want to, the PMP kit, which I want to build. I want to put onto my test bed at the side of me here so that I can check the sort of sensitivity of it, and I suspect it'd be quite good.
The one thing
and as you say, if you put it at an angle.
One thing I didn't realise when I built that little kit was that you can focus the laser. Maybe you knew that, but I didn't know that.
I haven't looked at the details yet. It's something for the future. I haven't even got all I've got going on this test bed is the ATC at the moment. The rest of it's a DCC layout, 4 ins to 4 ins, and I've got occupancy sensors, but I want to be able to put different types of contact sensors within that, and just check if there are any advantages, disadvantages of using a particular type of sensor over another, because it's not always cost. Sometimes you want, as somebody has said, you know, some sensors don't work in some situations, so or don't work well. Carry on,
Oh,
David.
yeah. Well, I was just saying, yesterday I was just testing, well, not quite a standard Hector, to actually distinguish the uncoupling point between coaches and wagons. Where Bill and I are doing some, work on this kind of thing, and I'm just testing out on the setup here. And I found that the Hector, you can distinguish the coupling point between the wagons. There is, if you adjust the sensitivity, but it then becomes a bit unstable. So you have to be quite careful how you use it. But it certainly does work in that you can pick out, you can differentiate between the space between the wagons where the coupling point is.
And how accurate is Torbin's magnetic and Hall effect device? Is that likely to be useful in detecting where a coupling is?
It's super accurate, because the magnet and the sensor, which is very small, align absolutely perfectly. But you've got the stopping distance to take into account, I suppose. It's what I use as a point detector to stop in stations and in all blocks. I have Hall effects everywhere as my point detectors for stopping.
Thank you.
Okay. We're coming to the end now, chaps. Next meeting is in December, the beginning of December, in a couple of weeks' time, and it's Dave Harris is talking about a large layout that's automated as part of the. He's been in charge of the control aspects of for his local club, so that should be quite interesting. It's always interesting to see how things have been applied rather than just discussing the theoretical aspects as we have today. So thanks for joining, and I'll see you December the 3rd.